know that the thing is recommended. It, it is based upon your needs and your use cases. If it satisfies your use cases, then yes, it is a recommendation. If it doesn't, then it is not. If Flutter satisfies your use cases, your requirements, then just go with Flutter. If it doesn't, then just go with CMP and KMP. Shahid, sorry, I won't be taking any questions at this time. We can discuss these things at the end of this session. And most of the questions that you are currently asking are related to the previous session. You can rewatch that video as well. I also have another answer pending on LinkedIn. I will give that after this session as well. And today has been a very busy day for me. Okay, moving on to today's session. Uh, uh, the topic of today's session is just getting started with how Campy works. We will be going through some code, some documentation as well. So let's just start. Share my screen. Is my screen visible?
Yep.
Okay. So we will be primarily focusing on mobile side of things. What was used to be called KMM, a subset of KMP, Android and iOS. But later on, we will be migrating our project to desktop and web as well. So in this talk, we will be just talking about the Android and iOS side of the things, but it is same for all other platforms. The working of these things and how different parts of can be like the expect actual mechanism and the source sets, how these things work are same for different platforms, whichever platform you want to try out. Okay, I just uh, cloned this project from the KMP wizard, and if I open all these packages or modules and shift to project view, you can see that there is a compose app, there is a shared version of app, shared version where there is an Android main, a common main, and an iOS main. And in the compose app, there is only Android and common main. The reason for that is we will first start building our app with compose and Swift UI, uh, because most of people in our community decided that we should build an app from scratch. So we will start with Swift UI and Jetpack Compose, but later on we will discuss how we can use Compose inside Swift UI, Swift UI inside Compose, UI Kit inside Compose, Compose inside UI Kit, and things like that. Because the same principles will then be applied to desktop, where you can use Compose inside JavaFX, JavaFX inside Compose. So basically, this works two way around. You can use Compose in the native framework, and you can use the native framework inside Compose. So this is the plus point that we have over other frameworks like Flutter, like React Native, Ionic, or others. So uh, we'll start by discussing how the whole anatomy of a KMP project works. Uh, but before that, let's just head over. Uh, Tanish, I'll just share this project with different branches with particular like lecture one, lecture two on our uh, community GitHub, and that will make it easier for our members to understand and keep the code with them.
Okay.
Is the screen blurred to all of you?
Not mine.
Let me just zoom it a bit so things are clear. Okay, so I'm first sharing a tab so we can head over to the documentation first, and then we can start coding.
Hello, Kashif bro. We are not able to see the screen.
I'm sharing a tab. Just give me a minute. Is it visible?
Yep.
Okay. We are at the first page of Kotlin Multiplatform documentation. And here you can see there's a client platform and then there's a common multi-platform. So what this tells us that you can use Kotlin on Android, iOS, desktop, and web, and then you can use on server side as well. On server side, you can either use Git or there are other frameworks like I think one is called Orbit, and you can go old school and choose Kotlin side Java-based frameworks. And then we have the Kotlin multi-platform use cases, where the first thing is Android and iOS application. Although we have gone through this in the last video, but just giving a refresher here, you can use UI with Compose multi-platform, then presentation layer, which is the view model layer here, business layer, and data layer. All things can be shared. So this is the part where you share everything, UI and the business logic. But in the start, we will only be sharing the data part, the presentation part, and the domain part. And later on, we will start sharing the Compose multi-platform inside as well. Then you can head on to this part and check different multi-platform libraries for the alternatives of libraries that are written in Java for Android, such as Retrofit and other Jetpack libraries. Although most of them are now supporting KMP, but there are still libraries that don't. So this is a good resource to just get a good idea of how things are working in KMP. So this is the part where we are interested at this time. So on iOS, we can use iOS ARM64, which is for the ARM64 devices, iOS X64 for 64-bit devices, Mac OS, W64, and Linux. So basically, we can use all these platforms for sharing business logic. JVM is then again native, Android is native, iOS is again, Kotlin is native to iOS as well. This and we can discuss this in a separate lecture, but just keep it on the back of your head that Kotlin is native in iOS as well. It is then all inside a common main that in the common main that I shared in this screen that I showed you before this. Okay, so then we have Kotlin server side. It is complete documentation on how Kotlin can be used on the server side with AWS Lambda, Heroku, and there are some sample projects as well with Ktor and App Engine and things like that. Then Kotlin for Android, Kotlin for WebAssembly, Kotlin native. Okay, the interesting part here is Kotlin native. I won't go into details, and this is something that you guys will be learning by yourself how Kotlin native works, because when you are targeting writing some IS specific things, then it is not the Kotlin that we are used to. It is Kotlin native, and some functions, some extensions that we are used to might not be usable in that specific source set. For example, there are some math functions that are available in the common main or in Android, but are not inside the Kotlin native. Then Kotlin native can be interoperated with C and C++, Swift, and Objective-C. Although Swift support is not good, and you can practically not use that. Most of the interoperability that is built inside Kotlin multi-platform is dependent on UIKit and Objective-C, not on Swift. Although JetBrains has announced that they are working heavily on migrating all that to Swift and building a Swift interoperability just like UIKit and Objective-C, but there is no official announcement about that, how, when, or how this will be implemented. Then we can use JavaScript. data analysis, and everything. But if I move to multi-platform development, this is what we will be doing today. And and first, we will be understanding the basic project structure. First, there is the common code, which will be shared between different platforms. Then there are targets, the platform that we will be targeting. Like in the example here, there is JVM and iOS ARM64. So there is the code we write on in the common main for JVM IS ARM64. It is then converted to JVM class files like the Java class files and native executable for 64-bit IF1 devices. Just that the same thing that I described earlier, that Kotlin is native to iOS as well, because the code is converted to native executables that then run on 64-bit iPhone devices. Similarly, for JS, it is converted to .js files. Okay, the most important part of understanding the KMP project hierarchy is the source sets. A source set is a set of files that are used to compile a specific build flavor, for example, in Android, and a specific platform in Kotlin Multiplatform, like iOS, JVM, or some other platform. I know the documentation is a bit boring and frustrating for most of the developers, but just be with me. It is a very short kind of documentation overview that we will be going through, and then we will just start coding. Similarly, iOS ARM64, JS, and everything is converted to native executables, which then run on that specific platform. So Kotlin is native to all the platforms that are supported by it, like JVM, Mac OS, or any other. So these are some examples of other source sets in iOS ARM64, Mac OS. Then, if you want to target Watch OS, then if you want to TV OS, then you have to define these inside the Kotlin block. Okay, I think this is enough for all of us. Let's start doing some coding. Is there any question till now?
Yeah, hi Kashyap. Just one quick question. So, how
Yes.
different is it from Dart file? Sorry, Dart language. So, because that also we can develop in for all the iOS as well as Android, right?
Okay.
So,
Dart is a language and Flutter is a UI framework. Okay.
correct. Yeah.
First of all, we have to make a few things clear. Flutter is a UI framework. Dart is a language. Dart can be optimized to run anywhere. Flutter can be optimized to run anywhere, just like Compose Multiplatform, just like Kotlin Multiplatform. However, on Dart side, Dart isn't native to that platform. There are a lot of wrappers around that. When you convert a Flutter code, for example, Flutter uses Skia for UI rendering, and now it uses Impeller, but previous to that, it used to uh, have Skia bindings for running the app on iOS. So just like Flutter, uh, Compose Multi-Platform also uses Skia, not Skia, but a wrapper around Skia called Skiko, which is used for running that on iOS. So there is much difference, but the main difference lies how this is compiled for that platform. When Kotlin is native is compiled, it is converted to that. For example, I haven't compiled this project, but once we do that, I will just show you how things are being converted. So this is being converted to Objective C and similar kind of bindings, which then helps it to achieve the same speed, same performance as native platforms. For example, if you write an app in Kotlin, you just share the business logic and build your UI using Swift UI or Objective C, the performance will be exactly the same as the native platform. Then another factor that gives Kotlin Multiplatform an edge over Flutter is that you can use a native UI framework like Swift UI or Objective C and use Kotlin for building the for building the business logic. In this way, there are no limitations. With Flutter, there are limitations on iOS side. For example, what is the wrapper called that is used to generate UI widgets, iOS like UI widgets on Flutter? Uh, Can anyone remind me of that? There is a specific name to that. Uh, Cupertino. So for using iOS like widgets, you use Cupertino design system for iOS on Flutter. But using Compose multi-platform and Kotlin multi-platform, you can, instead of using Cupertino, which is a wrapper, you use platform specific UI components like video players or other tab bars. Basically, you can use every UI component that is available in UI kit uh, with Compose. And does that make sense?
Yeah. Yes, Kash.
Yeah.
Thanks.
So with Flutter, you cannot use Swift UI inside Flutter. You can use UI kit inside Flutter. But with Compose multi-platform, you can use Swift UI and UI kit inside Compose multi-platform. So the basic thing that I want to make clear here is that if you use KMP, just plain KMP without Compose multi-platform, you achieve the speed and the performance of native language on different platforms. If you use Compose app with KMP, you achieve the same UI performance, same UI components, and same business logic, speed, and everything, just like the native platform. This gives an edge. uh, uh, this gives KMP and CMP an edge over Flutter and other frameworks like Flutter. Is it? Do you have any more questions?
Yep. Thanks for the explanation, Kash. It's like Kotlin and Java, which we used earlier for the interoperable. Like that, we can use it over here.
Sorry, folks, I have a call. I'll be back in 2 minutes. Okay, so it is similar to what Java used to do. It build once and run everywhere, but still it is different at the same time because how is things are working under the hood. This is how it differentiates from Java. But when we will be discussing these things in more details, it will make more sense to you. Okay. So we discussed that there is something called common, and there are a few things like uh, what they were called. source sets, and platforms. So if you go to the build.gradle file of your shared module, so basically these are just modules, just like any other module that you might have in your Android app. So if I just close this, these are just modules, nothing more than a module. This is a shared module. This is an app module that every Android app has. Uh, Give me another. So yes, I have been on road the whole day, so I'm not being able to give you the same energy as the last session, but just be with me. Okay, so just like any build.gradle file that you might have in your Android app, there are three build.gradle files. One is the project level, then your app level, and the third one is the shared module. Let's start from the top. So in from the top, we have only two plugins. One is the Android library plugin that you might all be aware of. The other is a Kotlin Multiplatform plugin. In the last session, we discussed that Kotlin Multiplatform is just another SDK that you can add or remove at will in your app. Like you want to use Glide, you want to use Coil, you add it, you remove it. It depends on your needs and what you want to use and what you don't want to use. You want to use Crashlytics, you add. If you don't want to use Crashlytics anymore, you just remove it. Similarly, from this module, if platform doesn't work for you, just remove this plugin and there will be no Kotlin multi-platform in your app. And just like that, you can add and remove Kotlin multi-platform your app. It is an SDK. Use it if it fits your needs. If it doesn't, remove it. It is you are not dependent. Like Samir said, what are the differences? Once you build an app in Flutter, you are bound to use Flutter. But if you build your app with Kotlin multi-platform and Compose multi-platform, then one day that you decide or your management decides that we don't need this anymore, just remove it. Nothing will happen to your app. Okay. So inside Kotlin, there are some targets. The first one is the Android target. As the name suggests, it it helps you build the and it basically tells the Kotlin the whole Kotlin block that we have an Android target, that we will be using this module or this library inside an Android app. Then we have a list of iOS platforms. There is iOS 64, ARM 64, simulator ARM 64. So you can study how these architectures work on iOS. But if I just want to give you a gist of it, this is what iPhones um, prior to I think 9 or sorry not 9 iPhone X prior to iPhone X had. This is iOS ARM 64, the new architecture, and then this specifies that we want to run this app on the simulator as well. For example, in Android, we used to define something similar to this inside the NDK block, where we tell our app that you should be compiled to only the platforms that I have written inside the NDK block, not any other platform. This then reduce the APK sizes. This then made the build time a bit speed, this reduce the build times. And similar to this, inside Kotlin multi-platform, we have these targets where we define which platforms we want to target. We want to target Android and these platforms of iOS, and then we tell the list that for all iOS targeted platforms, generate a framework. So framework is we can okay, framework just a library like the dependencies that we have in our Android app, or .jar files will be a very good example. A framework is just like a jar file that we use in our Android app. And inside iOS, we use XC framework, which we are telling our build.gradle file that generate. Basically, we are telling Gradle that generate a framework for these platforms only. If I add Mac uh, OS 64, I will have to import it, I guess. Mm, Okay, I think I have made a mistake. Mac OS. Mac. I don't know why it isn't auto completing. Okay, so basically the point is you can define your targets there. WatchOS, macOS, or any other platform that you want to target. And then here you are telling this that generate a framework for all these platforms. You can also use the cohorts if you want. We will be moving on to cohorts lately, but at this time we are only using an XC framework. You can search on this what XC framework is actually is and how this works. Then we have the source sets. So you can consider the source sets similar to what flavors are inside Android. Whatever you define here can be accessed in this. For example, iOS main, and then you can add your iOS dependencies there. But for adding iOS dependencies, you need to have a dependency manager such as Cocoa Pod. Swift Package Manager, for those who know what Swift Package Manager is, uh, it is not supported by KMP at this time. There was a plugin, a community plugin uh, for handling, for converting the code to instead of a Cocoa Pod or framework. It was used to convert the code into a Swift package, but it is no longer being there's no work being done upon that. And there's something called the KMP bridge, which can now be used to generate a Swift package manager, but that is something for the later sessions. So inside common main, for example, if you guys have developed apps for Huawei, app gallery, what you do is you add dependencies for Huawei separately, and then you have regular dependencies as well. And then you have flavor for Huawei, and then you have a flavor for normal Play Store. So consider that, and similar to that, inside common main, you add dependencies that are supported by the shared module, which you can share between iOS and Android. And then there is Android main. In here, you can add all the Android dependencies that are only used inside Android, that are Android specific dependencies like retrofit or any other dependency that Android that you want to use. Similarly, in iOS main, like we have discussed before, you can see that there are also different other mains as well. So for now, we are just using iOS main dot dependencies, and inside here, you can add the dependencies that you want to use on only on the iOS side. If there is a dependency that is supported by common main, Then you can add, and you don't want to use in common main but only want to use inside Android or iOS. Then instead of declaring that in common main, you can then just add those inside these mains, like these coroutines.android, although this doesn't exist in my project, but just a suggestion. And inside iOS main, you want to use, for example, Cocoa Port extensions. There's an extension of Cocoa Ports that you can do like something like this, or and name shared is like this. And in the end, there's the Android specific extension. Uh, if I go to the Android build.gradle, so this is the equivalent of this, because again, this is just another module inside your Android app, nothing more than that. This is just a module inside. This whole shared module is just another module inside your Android app, and just like any other module, you have to add the Android extension here, define your compatibility. You have to define the minimum SDK, your max SDK, sorry, the compile SDK, your namespace, and all those things. Okay, any question here?
Yeah, just only one. Sorry for the interruption. In the target list, in the iOS simulator, in the last line, could you please add comma and the check once? Yeah, there at the end of the line, could you please add comma?
This one?
No, not in the next line, next end of the line. No, in the simulator line. Yeah, there. Could you please add comma and try the Mac OS that
Oh,
which you,
sorry, I was missing the comma. Thank you.
yeah.
Thank you. Okay, so now you can see there's Mac OS ARM64. We can add watch OS device ARM64, simulator ARM64. Then was WebAssembly JS. You can use JVM, and you can declare uh, a custom source set like desktop. But then again, we will actually cover that in the next session. But there are some predefined targets that you can add in the list, like WatchOS 64, and it will generate a framework for that source as well. Okay. Uh, Now, is the source set, what is a source set, is clear to all of you? Is there any question related to what a source set is? Any question? Okay. So just like source sets, as we discussed, they here we have our common main, which is the common source set, where whatever we write inside the common main will be shared among different platforms. Then we have the iOS main, where only iOS specific things will be written. And then here we have, if I switch to project view, we have the Android main. Everything related to Android will be written here. If I switch back to Android, you can see there's some other source sets, uh, like the Apple test, Apple main. Then we have iOS test, iOS ARM64 main. Then there's native main. So there are different techniques or how you can use source sets inside your app. For example, if I want to share something among different iOS, um, how should I put it? If I want to share something among all different iOS versions, or all different platforms, Apple platforms like watchOS, iPadOS, and macOS, iOS, then there's the Apple main. I can write that inside Apple main and it would work. But for that, I will have to make all the other source sets like iOS, these all dependent on the Apple main. If I go to build.gradle, I can write Apple main dot get dot depends on common main. So what this essentially does is that Apple main depends on common main. Similarly, I what I can do is iOS main dot get dot depends on Apple main dot get. This tells Gradle that iOS main actually depends on Apple main. So if I sync this, you can see that the source sets on inside my project have changed. Now we don't have an Apple main. There is only no iOS main, no Apple main. But if I go to project, the iOS main is still there, but it is not highlighted now. Reason? Because the dependencies have changed. This is a difficult and long topic, so we will discuss this in details in some other session how these things work. But basically, you should have an idea that we can use one main to write all the Apple logic. If everything you want to share can be shared among iPad, Mac, and iOS and watchOS. But there are times when this cannot happen. Then we can also use native main. But at times you will, most of the times, being mobile developers, you will only be using the iOS main. So we will be discussing that in details. But but later on, we will discuss all different mains and how these things work. Okay. So when Smear asked the question about differences between Flutter and KMP, I said that you can use platform specific things that Flutter cannot use. So there's this function called there's this expect function. So there's a mechanism in Kotlin Multiplatform which is called the expect and actual mechanism. So what the expect actual mechanism does is that to write a function, this can be a property where x of type int. This can then be a expect object. This can be a expect class, or this can be a expect function. So what does the expect means? The expect keyword means that for this particular value or for this particular function, for this particular property, I want an answer from every targeted platform. So currently, if I go to our shared module, the targets we are currently using are Android, iOS 64, iOS ARM 64, and iOS Simulator 64. All these three are then wrapped inside iOS main. So when we compile the app, it will ask, where's the phone? So this keyword will ask the compiler that give me an actual implementation, a concrete, it is similar, it can be described as how interfaces and implementations work. So this expect function will ask the compiler, okay, I don't have a body, give me an implementation for each of the targeted platforms. So if I click on the A here, which is for the actual method, there is an actual implementation of this platform, just like how we define an interface, and then that interface is implemented by a class. Similar to that, this expect function does not have a body, and the body is then is provided by an actual function for each and every platform. This is how we can use platform specific logic for our platform. For example, here UUID is sorry, device. Uh, I think I should just okay. Let's just use this for demonstration purposes. Here, UI device dot current device dot system name is an iOS function. This written in Kotlin, but the functionality uh, is an iOS functionality. On Android, we write like UUID dot random dot UUID, but this is not available here because is an iOS source set. If you look at the import above, this is platform.uikit.ui device. So this UI device class or whatever this is inside the UI kit package. And we are actually using the UI kit inside a Kotlin multi-platform app. This is how it is differentiated from Flutter, React Native, and other frameworks like that. So we are using an actual iOS functionality inside Kotlin using Kotlin. This class then returns an iOS platform, which is of type platform, and this is the interface which is implemented by iOS platform and then also implemented by Android platform. So inside Android, we use the regular build or version SDK, and inside iOS, we use the UI device current device system name. If I run the app now, so I have run the app on Android, and it is giving the current Android version because we are using the code here build or version .sdk, and I have started compiling the iOS app in the background. So any question till now? No questions?
Hi, Kashif.
Hi, Purpose.
Yeah. So my basic question was, how do we create this project for other multi-platforms? I think I missed out that part.
Okay, so uh, if I go back to the shared part, you can define different platforms here. For example, you can define JVM, You can give a name to that platform, but if you just want to call this JVM and JVM main, then uh, there's nothing that can stop you from that. And similarly, if you want to declare WASM.js, I call this WASM, I don't know what it is actually called, WebAssembly.js. You can define that here as well. And then the project will start targeting WebAssembly and JVM as well. It is as simple as that. And then just like this, inside source sets, you can write JVM main dot dependencies, and you can add JVM dependencies and WebAssembly. I think WebAssembly is just JS main.
So you are telling like when I sync this project, automatically those packages will be created for other
Yes, if I
platforms.
yeah, if I sync this project, now you can see the JVM main is has been created and JVM test has been created as well.
Okay, got it.
We will be moving on to JVM and JS in the later sessions, but for now, in this session was just an anatomy. What source set means, what how Kotlin Multiplatform Gradle file uh, can be read and understood, and things like that. In the later session, we will start discussing JVM, JS, and other things as well. Okay, Dan, I will be taking your question. Just let me share my iOS screen. Okay, is it visible?
Yes.
Okay, now if I click here, it is Swift UI, and inside Swift UI, we are sharing our build logic from Kotlin. And this iOS 17.2 is coming from the code that I showed you guys earlier, where we are using UI kit inside Kotlin, written in Kotlin, and we are accessing the UI kit functionalities inside our iOS main. Okay, that was all for today. For today's session, would have been only discussing the anatomy, but we have gone through a bit more. Uh, but from the next session, we will start implementing our app. Okay, so I'm stopping the recording now. If you guys have any question, you can ask.